Going live. Okay, well, this thing does work now. I'm going to give people a moment to kind of get into the chat. These graphs are a bit more true to life. See, here's the thing. You guys, when you were in like basic algebra, you learned like straight lines. When you throw a ball to somebody, or if a rocket launches from Europe to America or some junk like that, does the projectile go in a straight line? If I throw a ball to you, does it go in a straight line? No, what is it going? Yeah, like a curve, more like a parabola. But in a perfect world with a parabola, yeah, I mean, that's a bit more true to life. But the problem lies in the fact, well, there's friction due to gravity. Yes, there's gravity, but there's also friction. There's a lot of weird stuff going on. We learn all of these perfect equations, linear equations, quadratic equations, square root equations. But these equations are actually a bit more true to life rather than anything else. So let me just leave something in the chat because a bunch of people are popping in. Can you guys hear me now? In the chat, my apologies. The cold stream lost audio. There we go. Fixed it. I took a picture. There we go. Of the chat for attendance. Please leave a new comment. Just in case. Okay. Let's see. Post. There we go. Excellent. So we'll figure this junk out. Anywho's, it's like I said, I wanted to reintroduce you to factoring because first we need to relearn how to factor. Then we are going to apply it to simplifying problems like this. Then we're going to apply it to solving problems like this. And then eventually down the line, I'm going to teach you how to graph problems like this. They're very entertaining for me. I like them. Anywho's, we are back to our notes right here, reintroduction to factoring. Now, there's one very basic form of factoring that you guys have done for years and years and years, and it comes down to three majestic letters, G, C, F. Of course, they stand for what? What does one stand for? Greatest common factor, of course. This is probably the oldest form of factoring that you guys have learned. This goes back, I don't know how far, middle school, late elementary school, things of that nature. Some of the examples that I can give you, I'll give you a couple of basic examples in regards to greatest common factor, because greatest common factor is a form of factoring. I look at something like this, and I ask you, well, what is the greatest common factor? Yeah, I know. It's like, again, there's like a middle school thing, or earlier. I don't even know. But 2, it has a 2 in common. So I can take that 2, and I can rip it out. Actually, not just rip it out, more specifically, divide it out of each term. And when I divide it out of each term, I'm left with the following. This is now factored, solely based on this simple thing called a greatest common factor. You look at what each term has in common, and if they happen to all have the same thing in common, then you can divide them out and leave it on the outside. Here's another example. For this example, what do they both have in common? Move that up a bit for people. What do each of those terms have in common? Yeah, technically they both have 1. That's a common factor, but what is the greatest common factor? Because it doesn't always have to be a number. Yeah, they both have an X in common. And since they both have an X in common, I can take that X out like such, divide it out of each term, and I'm left with the following. Now, I want you to notice something. I want you to notice something here. Notice that I got the same parentheses for both ends. I got the same parentheses. They're both an x plus 3. The only difference between them is the greatest common factor, even though they look completely different at the beginning. Looks kind of insane. Let me ask you one more before I take it up a notch. What if I had the following? What would be the greatest common factor in this new example? Let me move it up a bit again for people to see in the chat too, because the glare. I got a lot of different answers from people, Friday, in my B-Day class. Ooh. Somebody told me 2, and I said, sorry, it can't be 2. And they said, why not? And I'm like, well, the first term doesn't have a 2 in common. Okay, well, then the greatest common factor is x. And I said, no, it's not, because the last term doesn't have an x. In order for it to be the greatest common factor, all 3 terms must have the same term in common. What's the greatest common factor? It is just 1 here. Yeah. The GCF here is indeed just 1. They all have to have the same thing in common. They all have to. Doesn't matter if most of them have it in common. All of them have to have it in common for the GCF to work. So in the beginning of the year, I reminded you about this concept of greatest common factor, which is a step in factoring. And then, I showed you the Tucker method. Like I said, this is a reintroduction to the Tucker method, or to factoring in general. Now, the Tucker method was a method of factoring, but more specifically, it was a method of factoring quadratics. Quadratics in the form ax squared plus bx plus c. It was a method of factoring quadratics. We need to know how to factor quadratics for this new chapter. Now, if you know a different way of factoring quadratics, that's perfectly fine. That is perfectly fine, as long as it works. If you have a way of showing the work and backing up your way of factoring, by all means, continue doing that. But I'm showing you an alternative, which is, again, something I showed you in the beginning of the year, the Tucker method. Eventually, we'll have to show you other things, but we'll get there. There were 5 steps to the Tucker method. 5 steps. Step 1, well, we've already talked about it. Step 1 was GCF. Always double check to make sure that you are taking out the greatest common factor. Now, for the rest of the Tucker method, this is where it got a little like, oh, this is new stuff. Kind of. It's kind of new. Step 2 was to multiply A times C. This might be coming back to some of you. If you multiply A times C, now where are the A and the C coming from? Well, they're coming from right here. A times C are coming directly from that quadratic in that form. And when you multiply them together, you just get a result. All right, some kind of a number. Yes. And now you're ready for step 3. Because step 2 is literally just multiply them. Step 3 is where the magic happens. You need to find 2 magic numbers that multiply to A times C and at the exact same moment, add to B. Step 3 is the most important step, where you had to find two magic numbers that multiply to A times C and at the exact same moment add up to B. For the most part, these numbers would exist, but there are certain instances where the numbers don't exist. And I will talk about what you would have to do when that situation arises. Once you have those two magic numbers, you would organize that information into a T-chart, which I'm going to remind you of what you would have to do for that, slash simplify, which again, I'm going to show you what simplifying means for the Tucker method. And finally, step 5, in which you actually write out the factors. Now, I'm going to show you a few examples. I'm going to walk you through each of these steps. And then I would like to take that quizzes, a practice quizzes, practicing, well, these old things, this reintroduction of information. Eventually, it just comes back to like riding a bike. I don't know. It depends. Let's try something. Let's try an example here with the Tucker method. (2x squared plus 7x plus 6. This part right here? Maybe the bottom few steps? Okay. I just want to make sure I can have both up here. I'll leave it up here for a little bit. So we got 2x squared plus 7x plus 6. Now again, just walking through the Tucker method. Step 1, GCF. If I'm going to try and take out a GCF, I got to look at all three terms, see what they all have in common. Well, just like before, 2 of them have an x in common, 2 of them have a 2 in common, but not all 3 have the same thing in common other than 1. And if the GCF is just 1, you can't do anything. So move on to step 2. Step 2 is to multiply A times C. In this case, it's a 2 and it's a 6, and I get 12. Then step 3, find 2 magic numbers. Now this again is the most important step. You have to find 2 numbers that multiply to give you what you just got from the previous step. 2 numbers that multiply to 12, which you have a lot of options for, but at the exact same moment. Those 2 numbers also have to add up to the B value. Yeah. Doesn't matter what order you give them to me in. You're hesitating. It doesn't. It does not matter. You could say 4 and 3. You could say 3 and 4. Doesn't matter. Some people do have those kinds of questions. Sometimes when it's like positives and negatives, yes, it does matter which one has the negative, because they do have to add up to the B value. But in this case, 4 and 3, 3 and 4 doesn't matter. T-chart. Now, this has been a while. I put my 4 and 3 in the bottom, but this has been a while. Does anyone remember what the heck I put in the top? Say again? I'm going to put some kind of an X. But do anyone remember precisely what I put, though? Definitely going to be the X's, though.
2x.
2x and what?
1x.
Not precisely.
2x
2x and 2x, yes. Let me explain why. Let me explain why. Because this is important. It's been a while, mind you. It's been a while. Eventually, this 2x squared has to be broken up. And this 2x squared can be broken up as a 2x and a 1x. Yes, absolutely, like you just said. Because 2x times 1x, 2x squared. Yay. But remember before I asked you about the order, about 4 and 3? That doesn't matter, 4 and 3. But here, is it a 2x and a 1x? Or is it a 1x and a 2x? I don't know. I have no idea. So instead, temporarily, this 2x squared is going to be written as 2x and 2x. I'm just simply going to repeat it. The x breaks down with x and x, but the 2 is going to go with both, 2x and 2x. I say temporarily because something is about to simplify. It says t-chart/simplify. And when you simplify, you are going to be simplifying a fraction. In this case, the fraction 2 over 4 simply reduces to 1 over 2. And that's literally what I'm going to do. I'm going to simplify them to make them a 1 over 2. The other fraction, you should check as well. The fraction 2 over 3. Oh, snap. 2 over 3 doesn't simplify. Then leave it. If it doesn't simplify, then leave it. Then step 5. Write the factors. You would write them vertically. Vertically. Here, after I simplified, it vertically becomes 1x plus 2. Or just x plus 2. And the other one becomes a 2x plus 3. These are my factors. These are my factors. I know because before you said 2x and 1x, because yes, the answer will have a 2x and a 1x in it. But the order that they're written in, it's like, what do I do? T-chart. If you can master the T-chart, the order of all things will be taken care of. It's kind of messed up. Let me see here. Okay. Now, this is a reintroduction. It has been a minute since we've seen stuff like this. I want to see what you can do with just a small reintroduction. This is a small reintroduction. But right now, I want to get in a practice quizzes. So, for those of you here, break out them Chromebooks, because we're about to knock out this practice quizzes. Now, obviously, we are not going to just, leave this alone. I need to have all of this taken care of. I need to make sure we revisit this information. I want to see how good we are with limited review. This is a practice. For those of you in the chat, I want to see you log on as quickly as possible. The code is right there. I'll type it into the chat just as a precaution, although I do believe you can see it now. 356488. There we go, 356488. Good. Let's see what we got here. I would suggest having some scratch paper, just in case. Obviously, you have your calculators on your Chromebooks. But having that scratch paper can definitely be helpful in certain instances. Let's get ourselves logged on as quickly as humanly possible. Bum, 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 bum. Joinmyquiz.com with 356-488. Yes. Just for the sake of argument, again, being that this is a practice quizzes that you guys are jumping onto, a practice quizzes, I did turn on redemption questions just for fun. I don't know, just for funsies. Not everyone's logging in. I mean, I know obviously some of you guys are still trying to get into the computer in front of me right here, but I'm looking at the people who have signed in so far versus the number of people who are supposedly in the chat. They need to get in there. And they'll realize after the fact or something along those lines. But I want to get you guys started as soon as possible. So while you guys are finishing logging in, I'm gonna obviously make sure that you do that. I'm going to click start just so we can get this thing moving. Here we go. Obviously, the code will still be at the top of the screen. It will still work for you to log in. Actually, I can't believe they actually installed all those things around the school. Yeah. Insane. We'll let the quiz go for about another minute or so as people are wrapping it up. I would like to look at one or two questions that are in the red in terms of questions that we've done, but we'll see about that in a minute. Okay. Click it there, click it there. Bum bum ba-dum, bum 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 ba-dum, bum 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 ba-dum, bum 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 bum. Oh no, not everyone did. I said I was gonna finish it. Remember? Yeah, about a minute or so because I wanted to go over some questions. I only got about 8 minutes left. Sweet. We had none in the red. Well, there we go. There's the first question we're going to go over. So I would like to put these into our notes. But this question was the most troublesome question. Looks about half of you got it wrong. That is okay. This is a concept that obviously we've covered in the past, but a concept that I had not covered today. But they wanted you to solve a problem like this. So I am putting this into my notes, as I would suggest that you do as well. Looking at this problem, they want me to solve by factoring. One of the things that we've talked about in the past is the fact that the equation has to be equal to 0, which it is. So I'm going to go ahead with factoring. First step, greatest common factor. Well, greatest common factor is a 1. Because 5 and 13 and 6, it's a 1. So I'll move on to A times C. A times C, 5 times 6 gets me 30. 5 times 6 is 30. I got to find two magic numbers. Well, 5 and 6 multiply to 30, but 5 and 6 add up to 11. 15 and 2. 15 and 2. But 15 and 2 add up to 17. Shouldn't take that long to figure out. 10 and 3 are your magic numbers. They multiply to 30 and they add up to 13. Put those magic numbers in the bottom of the T-chart. As we discussed before, because it's a 5x squared, you're going to write it as 5x and 5x temporarily because you're going to have to simplify some junk in about a moment. 5 over 10 reduces to 1 over 2, and 5 over 3 reduces to 5 over 3. So you leave it. I can write my factors vertically here. It's a 1x plus 2. And vertically right here, it's a 5x plus 3. But this is not where the problem in the quizzes wanted you to end. The problem in the quizzes wanted you to keep going and wanted you to solve. This is one of those properties that we have not discussed today, but we have discussed in the past, where if you have things being multiplied to give you 0, one of them has got to be 0. And since we don't know which one is 0, we have to assume that either one of them could be 0, and we have to solve. This is where we end up with two answers, a -2 and a -3/5. I'll check that against what's in the quizzes in a moment. I just want people to have the opportunity to kind of jot that down. You got to factor. And once factored, you can set each of the individual terms equal to 0. If I look at the quizzes, -2 and -3/5 clearly is the answer. And I can see that the rest of people chose answers that were kind of strewn about the rest of the way. Okay. Let's see what we got here. Oh, interesting. Yes. Let's do this one. This will be the last question we do today, and I can see exactly why. This one popped up the way that it did. 3x squared plus 18x plus 15. By the way, one of the choices on this thing was a prime. Give me an example of a prime number. Say again? Somebody whispered it. I thought they did. Name any number. 2. 2 is a prime number, technically. That's what I'm saying. What else? Name another prime number. 10's not prime because you can divide it by other numbers other than 1 and 10. That's the key. You can't break up the number, you can't break up the number 7. You can't break up the number 29. You can't break up the number 53, 5, 31, 43, 97, I want to say. 3, 89, 101, 103. You can't break them up other than dividing it by the number itself or dividing by 1. Thus, it is prime. If this were prime, 11, yeah, but if this were prime, then no such magic numbers would exist. If this were prime, then you would not be able to factor this. But you can. A lot of people forget greatest common factor. Or they remember greatest common factor and then again forget it later on. You got to take out that 3 as a GCF. And when you do, now your A value is 1. So A times C is 5. Can you give me 2 magic numbers that multiply to 5 and add up to 6? 1 and 5, yeah, they're the only ones that work. T chart, 1 and 5. It's a 1x and a 1x. Nothing simplifies. I get an x plus 1, x plus 5, which, if you look back at the quizzes, about half of you chose that one. About half of you chose that, and it was wrong. Because you forgot that 3. That 3, what 3 letters represent that 3? The first step of the Tucker method? GCF. Greatest common factor. It's a factor. And since it's a factor, you cannot forget to bring it down with the other factors. That's a fact. Again, knee slapper. Nailed it. Anywho, on Wednesday, we will be knocking out this benchmark. Please make sure you bring in those Chromebooks. We'll get this thing done. Bell's going to ring. If you haven't left a comment, please make sure that you do, because I've already updated my attendance. And I will see you guys on Wednesday. Click.